Okay, lesson one of our linear relationships unit. This is going to be a really important unit for grade 10 math. This skill of graphing straight lines is something that's just going to be expected that you know how to do. So we've already looked at this a little bit. The equation of a line in slope y-intercept form, y equals mx plus b. So when I look at this graph, there's a lot of things that are really important to know. I want to know what the slope is, and I also want to know what the y-intercept is. The y-intercept's easy. I can just look at the y-axis, and I see right there at -5, the y-intercept is -5. That's where the line crosses the y-axis, so that's something really simple to notice. The slope, I see the line is going up, so it has a positive slope. I also need to be really careful about the points I'm looking at. See that point there is not really on the corner of any of these squares, so I don't really know exactly what that point is. I see a clear point here, and I see another very clear point there, and then I don't see a lot of them, but there's another one there. I see that the rise is 2, and this time our squares are always just worth 1 unit on a Cartesian plane like this. So 2 over 3. So I know the slope is 2 over 3. If I'm asked for the equation of the line, I'm going to say y equals the slope with a letter beside it. So we always have x beside the slope. And then -5 is the y-intercept. And it doesn't have a variable with it. It's always by itself. That will never change. It's always the same. So look at this one here. The line is going down, I notice. So if I need my m, these are the two key pieces of information you need, an m and a b. The b I'm starting with first because I think it's easier. I see the y-intercept right there is 3. That is also a nice clear point. Not good. Yeah, that one looks okay though. That's clear. I can tell what that is. And this one here, there's quite a few. So you can draw a large right triangle like that, which is 4 over 2 is the rise over run. Or you could do a smaller one like this and you get 2 over 1. What we talked about in the last unit, I could even draw one really large triangle here, but when I divide rise over run, or I reduce my fraction to lowest terms, I'm always going to get the same answer. So one thing you just have to be careful of, this line from left to right is going down, so it has a slope of -2 over 1. You could have said -4 over 2. When you're looking at slope though, I think it'd be really good if you just reduce that. -2 divided by 1, -4 divided by 2, we're going to get -2. That's a better thing to write down. Just simplify it as much as you can. If you can divide, then divide. So our equation would look a lot more simple if we said the slope, y equals mx, so the slope with the x beside it, plus 3. You can also write it like this, y equals 3 minus 2x. That is the same thing. The 3 doesn't always have to go at the back of the equation. It could go right here after the equal sign. It's still positive. It doesn't have a variable with it because it's the y-intercept. And the slope still has a variable with it. And it could come at the end. These are the same thing. That doesn't matter, the order. The y-intercept is always on its own, though, as a constant number. This one, okay, this is important. The slope here, for a flat line, we looked at this in our last unit, the slope is 0. The y-intercept is 4. If we had to write an equation, we could write 0x plus 4. But that's kind of weird looking. Like normally we wouldn't show 0 times x because 0x is just 0. So this sort of usually isn't shown, and your equation would look like y equals 4. Y equals 4, another way to think about that, y is always 4. No matter where you go, the y is 4. So this would be an equation for a horizontal line. Horizontal lines will just be y equals a number. When we look at a vertical line, we've talked about this before, how the slope is undefined. So if the slope is undefined, and then also we're trying to find a y-intercept, this line is vertical. It's never going to cross the y-axis. So there is no y-intercept. So what are we going to do about an equation like that? I can't say y equals 3 because that would be, or y equals 2, that would be a horizontal line. So vertical lines are always going to look the same. They're going to look like x equals 2. Because if you think about this line here, x is always 2. No matter where you go, up higher, down lower, x is always 2. So vertical and horizontal lines have their own sort of special equation. So horizontal lines, just y equals the number. Vertical lines are always just x equals the number. Example 2, the slope and y-intercept are given. Write the equation of each line, then graph each line. So if we were going to write the equation of this line, I'm hoping you can see that this is not a very hard thing to do. If I know the slope is 3/4, so y equals 3/4 x minus 2. You could write plus -2, but I mean, it's the same thing just to write minus 2. Either way, it wouldn't be wrong. So this one, we'd have to go to -2 on our y-axis. That is where we start. So this is the key skill. This is really important. You have to learn how to do this. This number, the y-intercept, is where we'd always start. On the y-axis, we go to -2. From there, we have a slope. This is rise over run. That means the 3 is suggesting you go up, and the 4 is sideways. This is still rise over run. From that point, from the -2, we would go up 3 and over 4. 1, 2, 3, 4. That is our line. And when we graph the line, I've been mentioning that it'd be nice if it was nice and long. So you want your line to go across your graph paper, and then usually what is a really nice thing to do would be to label your line on the graph. This next one, if the slope is -2 and the y-intercept is 0, you could write y equals -2x. You could write plus 0, but normally we wouldn't show that. It's not wrong to write plus 0, but you could just leave it off. So the y-intercept is 0 when I see that equation. That means I'd go on the y-axis to 0, and that's my starting point. From there, my slope is -2. That means -2 over 1. So if you don't have a rise and a run, remember you always make it a 1. That means you're going to go down 2 and over 1. So down 2 is the slope, -2 over 1. You always need a rise and a run. And what I'm doing, you can kind of see me repeating the pattern because I need this line to go straight. You wouldn't believe if you just had 2 points close together on a graph and then you use a ruler and you draw a nice straight line, how crooked it can go. So it's a good idea to repeat the pattern to make sure that your line is going to be exactly in the right place. I'm also liking that there's already an X and a Y on this graph. That's really important that you always have an X and a Y on your graph. This third one here, right away, the equations I don't think you'll think are very hard. Y equals mx plus b, just like that. We're just subbing in the m and we're subbing in the b. This is our starting point, so we would go up to 5. 1, 2, 3, 4, 5, and that's our starting point. So that's always first, okay? You always do this first, the y-intercept, because then from there, we're going to go down 1 and over 2. So the rise over run, if this negative sign is sort of in the middle between the numerator and the denominator, I would just suggest always thinking of that -1 being with the numerator. It tells you to go down 1 because it's negative and over 2. And from that 5, we go down 1 over 2, down 1 over 2, and we can kind of repeat it so we get a nice straight line. We can even go up 1 in this way and repeat the pattern. So that is our line y equals -1/2 x plus 5. A couple of weird ones here at the end. What if the slope is 0 and the y-intercept is 4? So I know the y-intercept is 4, so I go here. And then the slope is 0. So that means it's a flat line. It's a horizontal line. So going through 4, if I'm going to write the equation for that line here, maybe I'll do it up here, y just equals 4. And then another line that we could try and draw, what if the slope is undefined? That's supposed to tell you that this is a vertical line. And the x is -2, so this could be also an intercept at -2 over here. So if we have -2 and then a vertical line through that, our equation of the line is actually x equals -2. That's all we need for our equation of our line. So we're going to draw a vertical line through -2, and that would be x equals -2. So the only kind of strange lines are the vertical and the horizontal formulas. They're the ones that look very different. Okay, example 3, identify the slope and the vertical intercept of each linear relation and explain what they mean. And you can find the y-intercept is 5. That's easy to see. There's still a vertical axis here, and even though it's called the d-axis, instead of the y-axis, the variables don't matter that much, and so we've got a y-intercept of 5 and the slope. So this is going down, so you have to remember always that that is a negative slope. And let's pick some clear points. That's a good point. This is a good point. You have lots of points to choose from to do rise over run. So if we do rise over run, we just double check that these squares are actually worth 1 unit, and they are. So this is -1 over 2 would be our slope, rise over run. So if we're going to write an equation for that, we could do y equals -1/2 x plus 5, just like we've been doing. We could also say something like d equals, if this is distance, so it doesn't matter to me, but distance equals -1/2 t, because this is time, plus 5. So the variables you'll see sometimes are replaced with letters that make more sense to this equation. What do these actually mean, though? So the plus 5, she is actually starting 5 meters away from an object. That's what the 5 means. It actually has a meaning in this equation. The -1/2 is the fact that she is going closer to an object at a speed of 1 meter every 2 seconds. So we can say that Tracy starts 5 meters away from an object and walks towards the object. When we say that she's walking towards the object, we can't really have a negative speed, but when we put that in our statement that she's walking towards the object, that is taking into account this negative speed. Speed can't be negative. Another way, instead of 1/2 meters per second, we could say she's walking at 0.5 meters per second towards an object. The second one, if we look at this height of a tomato plant, so we have a line on a graph and we have a y-intercept at 6. So we're going to look at our slope and our y-intercept, and the y-intercept is 6. If we do rise over run, we're looking for clear points. There's some clear points. We could do rise over run. If I just did rise over run right here, this is where you have to be careful. This counts for 1. What do these 2 squares count for? These squares are being counted by 2. We're going up by 2, 4, 6, 8. So this doesn't just count for 2, the rise, it's actually 4. 2, 4. 2 spaces from 6 to 10, that is a difference of 4. So our slope would be 4 over 1 or just 4. We could write our equation, y equals 4x plus 6. For example, we could just use height equals 4t for time plus 6. So variables sometimes help you understand. We've got the height of the tomato plant. So what do these numbers mean? The B, that's 6. This is the height that the tomato plant is, I guess, when they bought it. This is at the beginning. 0 weeks, the height is already 6 centimeters. And I know it's centimeters because I'm always looking at my titles on my graph. So we know that the tomato plant started at 6 centimeters in height, and it grew every week. The slope is how much it grew in 1 week. So the tomato plant starts at 6 centimeters in height and grows at a rate of 4 centimeters per week.